Next, let's perform stepwise selection. So in our pull-down menu, let's change backward elimination to stepwise selection. I played around with this a little, so let's move it back to what you should have, the Schwarz-Bayes information criterion, and hit run. Okay, what are we going to get? Well, this shouldn't be a big surprise. Stepwise selection starts out just like forward selection does. And, well, forward selection got stuck with two variables in the model, and that's exactly what stepwise selection does too. Years and major were added into our model, and GPA was the next variable that could go in, but it turned out to not improve the model according to the Schwarz-Bayes information criterion, and so our stepwise selection stopped. It also checked to see if kicking out one of these variables was a good idea. It tried removing each of the variables. It thought major was the best one to kick out, but that made the Schwarz-Bayes criterion worse. You'll be noticing here that lower is better for the Schwarz-Bayes criterion. Okay, well, what can we do to change our results here? One thing that we can do is we can play around with the different methods by which we evaluate our models. So let's change here to the adjusted R-squared statistic. Now our method is going to evaluate models not based on the Schwarz-Bayes criterion, but instead on adjusted R-squared. If you read carefully above, I said adjusted R-squared tends to create larger models. That's just what we're going to see here. Okay, stepwise selection, added in years and major, but it didn't stop there. Now using adjusted R-squared, adding in GPA increased the adjusted R-squared from 89.15% to 89.58%. Then adding in gender increased it further to 91.43%. And that was our best model. Adding in usefulness would decrease adjusted R-squared, and removing the worst of these variables, gender, would decrease the adjusted R-squared. So we end up with this 4-variable model as our best according to adjusted R-squared. The graphs below actually illustrate what's going on here. We started off using the Schwarz-Bayes criterion, and the star here indicates that the 4-variable model is best according to the Schwarz-Bayes criterion, but perhaps looking at this graph you can see why we got stuck at the 2-variable model. The Schwarz-Bayes criterion improved when we added years of experience. It improved again when we added major, but it got worse adding GPA and then got better again adding gender. Because we are only looking one step ahead, we couldn't get over this hump, and so we chose the 2-variable model. Now if we look down here at the adjusted R-squared went up each time we added variables in, and so we ended up with the 4-variable model using adjusted R-squared. So this is why I'd suggest that you play around with these different methods for adding and removing effects, and possibly also for the others, in order to see which of these different methods will create different models that you could potentially use as your final model that you would want to use for prediction or interpretation or whatever else it is that you want to use your model for. Anything else interesting to talk about here? Not right now. There's our final model with GPA, years, major and gender included, and those are all of our parameter estimates.